As we know from our Algebra Basics tutorial, an exponent is a notation that arises from repeated multiplication. When we write a raised to the power n, or a, we're multiplying number a n times. But what if we only want half or 1/3 of that multiplication? That's when fractional powers, like representing square roots and cube roots. Now, let's build everything from just 3 basic rules. Rule 1. A to the power of x multiplied by a to the power of y equals a to the power of x plus y. Rule 2. A to the power of x raised again to the power y becomes a to the power of x times y. And rule 3. A to the power of -1 is simply 1 over a. There are some simple things that we need to remember, like a to the power 0 is always 1. 1 to the power anything is always 1. Also, a times b whole to the power n equals a to the power of n times b to the power of n. That's simply the distributive property in action. Every other rule you've seen, they're just derived from these. For example, what's a to the power of x divided by a to the power of y? That's a to the power of x times a to the power minus y, which becomes a to the power of x minus y. Let's simplify something that looks more complex. We simply add all the powers in the numerator and subtract all the powers in the denominator since the base is same. Fractional exponents are just roots written in a different way. And a to the power of m over n is the nth root of a raised to the power m. Consider this problem. First, raise 27 to the power 2. First, let's take the cube root of 27. That is 3. Now let's square that. So it's 9. Just like that. Let's visualize exponential functions with graphs. Here's the graph of y equals 2 to the power of x. Notice how it grows rapidly as x increases. If the base is greater than 1, the curve shoots upwards. If the base equals 1, it's just a flat line. If the base is between 0 and 1, the graph decays. It falls as x increases. Let's solve an exponential equation graphically. We draw both functions, y equals 2 caret x and y equals x plus 1. The solutions are simply the points where these graphs intersect. In this case, there are 2 intersection points, 2 real solutions. We see that the graph intersects close to x equals 0 and x equals 1. So we substitute it back in the equation to get that these are the exact solution. And that wraps up our journey through the logic of exponents. If you enjoyed this tutorial, don't forget to like and subscribe for more exciting math adventures. Comment below with your solution questions or thoughts.